Howdy. Little earthquake watch. Quite something going on. Also, in the middle of the Alps, close to the Matterhorn, which is quite a famous mountain. 19 hours ago, 1.412 kilometers in depth. And as you zoom in, you will notice that we are in glacial regions, blocked out parts for whatever reasons. Sechovia del Belvedere, al Belvedere. Here was the quake, approximately, I guess. So let's have a look at Sechovia al Belvedere. Google Earth. Lift to the Belvedere. Quite a big river for being up in the hills. Okay, there's snow and stuff melting. And we have a nice lake, which has this kind of turquoise color to it, which might indicate there is a limestone involved in the whole thing, and also other minerals. Obviously, it's also snowy. It vanished. But let's go back to the map, because I think the whole surrounding is also very interesting. Let's zoom out first a bit. So the flow direction is obviously this way. And I think the geology here is really, really interesting. Here we have the Sechovia al Belvedere. Belvedere means somehow like nice view or something, I guess. And this might be ice or it might be not ice. Let's see if we can see the actual end of the ice. Here we have the stream, which we just have seen before. Cascata del Roffel. Waterfall, maybe. Maybe that's the end of the ice. If it just would render the picture that we could see something. No, it doesn't. It's really, really interesting, the whole shape of those things. How can there be this kind of hole in this wall on the side? Morena view. That's really, really interesting altogether. I guess these lines might be paths where you can walk. There might not be any geological feature, but these are geological features, those lakes. There might be on the ice shelf itself, or maybe not. And also this one, just the shape it has, goes uphill and then goes down. Here it's the same. It's all around. Yeah, one could say this looks like a crater. Whoa. Yeah, I don't know. What do you think? Are we watching an actual volcano? Could be. Here we have this kind of perpendicularity. I just call it like that now because it is a repetitive pattern. And I don't know, maybe it has a real name, but at least in plasma science, plasma has this kind of perpendicular, how to put it, structures. Here's an example. Clouds are plasma. It's a really weak plasma, but it is a plasma. Here we have a line like that and then perpendicular features. And I've been in the city today, and you have to cross the river twice because there's an island in the middle. And I'm waiting for spring, going back fishing there. At the moment, there's no fishing going on. Obviously, there's ice all over the place. And the river is streaming into that direction. And if you watch the edge, or the whole edge here, you will notice, or you can see it already, it has this kind of perpendicular features to it. I try to zoom in a bit, but I don't know if you can see it. Yeah, you can see it, I guess. Yeah, that's not a really unsharp picture. So I guess with the video we do more. It's really interesting, this perpendicularity. This kind of this kind of standing wave pattern, and it creates this kind of pulse in the wave. Every time the wave hits, it creates one of these, and then next time it hits, and since the water is traveling in more or less same speed, and there doesn't seem to be any rocks nearby the surface or whatever would distract the flow of the water. That's why they are somehow really neatly equally spaced. But anyway, I leave it here. Thanks. It's really interesting. Watch the clouds and things, patterns all over the place. Bye.